As it approached Mars, astronomers made a discovery that changes everything. The interstellar visitor 3IAtlas showed mysterious metal signatures that do not occur in our solar system. Nickel without iron, traces of exotic elements, and a chemical composition that is difficult to explain. All of this suggests that we are dealing with a completely new object. Is 3IAtlas an ordinary comet, the fragment of a destroyed exoplanet, or even something artificial? The next few months will be crucial before it too leaves the solar system, taking its secrets with it forever. In May 2025, the TESS Space Telescope discovered an inconspicuous spot of light. Nothing that immediately looked like a sensation. But just a few weeks later, the Atlas Survey Telescope in Chile confirmed that this was not an ordinary comet, but the third known interstellar visitor to our solar system. After Muir and 3IAtlas's, we are once again dealing with an object that has come to us from outside the solar system. Since then, the attention of the global astronomy community has been focused on a small but highly interesting wanderer from the depths of the Milky Way, which has been given the name 3IAtlas. Measurements revealed other unusual characteristics, such as a drop-shaped coma, a long, fragile tail, and a chemical composition that in no way matches any of the comets known to us. The most exciting discovery was made by experts at the end of September 2025, when 3IAtlas approached Mars on its trajectory. Instruments such as a very large telescope in Chile and NASA's MAVEN probe registered unusual metal signatures, including nickel in almost pure form without the iron companions otherwise typical of comets. This finding, together with the astonishing ratio of carbon dioxide to water, raised questions. Is 3IAtlas really a normal comet or a previously unknown variation of interstellar bodies? Metals from a foreign world? 3IAtlas shows metal signatures that do not occur on Earth. When the first precise spectral data arrived, the surprise was great. Normally, astronomers find a typical mixture of iron, nickel, and other metals in comets in our solar system, and in very specific proportions. This combination corresponds to the conditions when the first building blocks of the planets formed in the protoplanetary disk around our star billions of years ago. But 3IAtlas revealed a different picture. High concentrations of nickel with almost no iron. This is logical because this body cannot have formed in the environment of our young sun. It originated outside the solar system and formed in the environment of another star. Nevertheless, researchers had previously assumed that certain combinations of metals and elements were the same or at least similar throughout the universe. This interstellar visitor revealed a puzzling combination of iron and nickel. Researchers assumed that these signatures are almost inseparably linked everywhere in the cores of planets such as Earth or inside asteroids. An object containing almost pure nickel contradicts, to put it scientifically, the current models of formation. To put it more freely, science is dealing with a combination that seems like a strange alien. Some scientists speak of a possible chemical signature of an alien system. But in reality, the discovery is an indication that 3IAtlas must have originated in an environment that is fundamentally different from ours. One hypothesis is that 3IAtlas could have originated from the remains of a destroyed exoplanet whose interior was unusually rich in nickel. When this planet was shattered by the gravitational forces of its star or a supernova, fragments such as 3IAtlas could have been hurled into space until they were eventually attracted by a star during their journey. In this case, it was our sun. Even more exciting is the possibility that the composition of 3IAtlas is not just a coincidence but contains clues to processes that we do not yet understand. Nickel plays a key role in modern technology. For example, in alloys used in batteries. Of course, it would be premature to immediately speak of artificial traces here. But the idea that metals of this purity point to extraterrestrial technology must be allowed. A cosmic laboratory on Mars. Never before has an interstellar object come so close to a planet in our solar system. The flyby of 3IAtlas at Mars on October 3rd, 2025 offers researchers such a unique opportunity that several orbiters want to study the object with state-of-the-art instruments. NASA's MAVEN and China's TN-11 are at the forefront of this effort. Both satellites are actually designed to study the atmosphere of the red planet, but their sensors are equally well suited to measuring the chemical and physical properties of 3IAtlas's coma and tail. During this unique opportunity, as early as late summer 2025, astronomers had excitedly calculated that the object's luminous gas cloud could become visible in the Martian morning sky. A spectacular spectacle not only for scientists, but also for telescopes on Earth. This is not just about beautiful images. 3IAtlas's comet contains gas and dust particles that provide clues to the deeper composition of its nucleus. In particular, the unusual carbon dioxide-water ratio of 8:1, which has already been measured in the infrared range by the James Webb Telescope, raises important questions. Such values are previously unknown in our solar system. No other comet ever observed by modern astronomers has shown such a composition. And we're talking about around 4,000 objects that have been studied. Hey, 3IAtlas is so unusual that scientists are being led to all kinds of speculation. Its proximity to Mars now allows this unusual signature to be studied from a whole new perspective. The MAVEN satellite could detect minute amounts of the ejected molecules and determine their isotopic composition. Such data is crucial to understanding whether 3IAtlas originated in a cold isoregion similar to the Oort cloud, or whether it carries remnants of a hot interplanetary system. TN11 in turn could use its radar to provide clues about the structure of the nucleus if particles from the alien comet enter its measuring instruments. Some researchers see the two orbiters as a unique natural laboratory on Mars, and the experiment shows that our science can be far more colorful than we thought. 3IAtlas is carrying material that has been traveling in isolation in interstellar space for billions of years, virtually unchanged fossils from a foreign solar system. While comets and asteroids in our own system have long been shaped by solar radiation and cosmic weathering, 3IAtlas's substance may still bear the original signature of its home. The Mars flyby is therefore much more than a spectacle. It marks the beginning of a series of experiments in which nature itself brings the interstellar visitor within reach. If 3IAtlas's flyby of Mars succeeds in collecting precise data, we could learn more about the diversity of alien planetary systems in a few months than we have in the last few decades combined. The last chance for important answers. 3IAtlas's flyby of Mars will only be the beginning. In the coming months, the strangest comet in the history of astronomy will enter a phase that is electrifying astronomers worldwide, and which could also represent the last opportunity to obtain real answers. After December 2025, the interstellar visitor will leave the inner solar system and return irrevocably to the cold, endless space. Since these objects travel through the universe on such wide orbits, they only pass us in a short and very fast flyby, and then interstellar visitors disappear forever. Comets within the system often return periodically. The same applies to asteroids, which are fundamentally bound to the gravitational conditions of our system. The perihelion passage at the end of October will be particularly exciting. Atlas will then race past the Sun at a breathtaking 245,000 kilometers an hour. At this proximity, researchers expect a veritable explosion of activity. Its unusual chemical composition, the extremely high CO2 to water ratio, and the mysterious metals could cause the comet's core to literally break open. Several observatories, including the James Webb Telescope and the European Solar Orbiter mission, are ready to capture every detail. If 3IAtlas breaks apart, we could get a unique glimpse inside it, a kind of cosmic autopsy of a comet. Even more spectacular is a view in March 2026. 3IAtlas will then pass Jupiter, and NASA's Juno probe could also briefly become a laboratory in space and enter the comet's dust trail. Even the smallest particle samples will provide revolutionary insights. A direct analysis of matter that clearly does not originate from our solar system would be a scientific sensation. Humanity has never had such an opportunity before. Some researchers even say that Juno could unwittingly become the first interstellar sample return mission. At the same time, excitement is also growing on the theoretical side. The nickel signatures without iron, the indications of titanium or aluminum, the retrograde orbit. None of this fits into the picture of classic comet models. If 3IAtlas does indeed contain fragments of a destroyed exoplanet, it would be the first physical evidence that such planetary catastrophes are not only conceivable but commonplace in the universe. This would have a massive impact on our ideas about planet formation, habitability, and even the frequency of Earth-like worlds. But there are also those who think in other directions. Could the metal signatures be an indication not only of geological processes, but of something artificial? So far, there is no evidence of this, but the idea that 3IAtlas could be a remnant or relic of a long-lost civilization is enormously fascinating, especially since its direction of origin coincides with the WOW signal of 1977, a mystery that remains unexplained to this day. Is the WOW signal a clue to 3Y? On August 15th, 1977, astronomer Jerry Emin heard a strong radio signal lasting 72 seconds at the Big Ear Radio Telescope in Ohio. The signal signature was so astonishing that he simply wrote "wow" next to the data. Since then, the famous wow signal has been considered one of the most fascinating clues to a possible extraterrestrial phenomenon. Never before and never since has a comparable signal been received from this region. It came from the constellation Sagittarius, a particularly dense zone of the Milky Way. And that is exactly where the trajectory of 3IAtlas leads back to. The direction from which the interstellar visitor originates corresponds remarkably well with the region of the sky where the wow signal was recorded. Of course, this could be a coincidence, but the combination of 3IAtlas's unusual chemistry, its metallic anomalies, and its origin in this mysterious region of the sky lends a connection of mysterious dimension. Some researchers emphasize that there is no direct evidence of connection, nor is there any evidence that 3IAtlas is a disguised space probe, as was suspected with Oumuamua. Nevertheless, the idea that 3IAtlas may carry material or even traces of processes associated with the same part of the galaxy from which the wow signal came is fascinating. One thing is already certain: 3IAtlas is forcing us to explore the limits of our knowledge. Whether it will reveal its secrets to us or leave us with many more unanswered questions will be decided in the coming months. Juno, Maven, and TN11 are literally the last chance to catch a glimpse of this messenger from the depths of the galaxy before it disappears forever.